the rest of this chapter, we're going to be looking at a single type of polygon called the quadrilateral. We're going to look at all sorts of different kinds. We'll start with a parallelogram. So a parallelogram is, by definition, a quadrilateral with opposite sides that are parallel. So you have a figure that looks like this. The definition of quadrilateral gives us this information. The opposite sides are here. So you have the quadrilateral below labeled QRPS with the intersection of the diagonals at point X. So these are the following theorems. I'm not going to prove all of them to you. Some of them will prove in class, but not all. So you're going to have to just take my word for some of these theorems. If you want to see the proofs for them, we can work with our triangle congruent proofs together if you want to look at this. All right, so let's take apart each of these theorems. If a quadrilateral is a parallelogram, then opposite sides are congruent. So QR is congruent to PS. And QP is congruent to RS. And next, if a quadrilateral is a parallelogram, then opposite angles are congruent. So angles opposite each other are congruent. So angle R is congruent to angle P. And then angle Q is congruent to angle S. And this next one you can think about. We know the sum of the angles inside a quadrilateral must equal 360. From the notes we took in 6-1. And we know that opposite angles are congruent. So we can go through a proof for this to show that the consecutive angles are supplementary. So consecutive means one after another. So in this case, there's 4 of them. So angle Q plus angle R equals 180. Angle R plus angle S also equals 180. Angle S plus angle P equals 180. Angle P plus angle Q also equals 180. So angles one after another are supplementary. They add to 180 degrees. And then the last one, if a quadrilateral is a parallelogram, then the diagonals bisect each other. So in here, those two would be congruent, and those two would be congruent on the inside. Those are just in regards to the red ones or the blue ones. So QX would be congruent to SX, and PX is congruent to RX. So the diagonals have each other in half. Try examples 1 and 2. See if you can come up with the missing sides and the missing angles in those parallelograms below. All right, so JH, we know opposite sides are congruent, so if FG is 23, JH must also equal 23. JK, the diagonals bisect each other, So those guys are congruent, and then those guys must be congruent. So JK also must equal 60. The last one, GH, opposite of FJ. So those guys, GH must be equal to 19. The angles now. Opposite angles are congruent. So angle A is congruent to angle C. That's 78 degrees. Now the measure of angle B. Consecutive angles are supplementary. So the measure of angle B plus 78 has to equal 180 degrees. Consecutive angles are one after another. So I'm going to subtract 78 from both sides. Measure of angle B equals 102 degrees. And then X has to equal, set that equal to 102 and divide. Divide both sides by 3. X equals 34. Next one. All right. This one is almost the exact same question for on the test. So a parallelogram is drawn in the first quadrant as shown. What are the coordinates of Birkhead C? So I'm going to figure out the coordinates of C over there. This gives us a general form in terms of variables, so we can plug in values for those variables and make it as big or as small of a parallelogram as we want. All right, so the first thing is, let's figure out our x. Our x is over z, okay? But it's also over this amount right here, this blue amount. That blue amount is the same distance x over that that one is. So I'm going to move that down here. So the length of, or the x coordinate is going to be z plus x. Z plus x will be our new x coordinate. Next, the y coordinate of this is how high it is. This is a parallelogram and it's set right here. These guys are parallel. So it has to have the same y coordinate as vertex B. So the coordinates of point C are z plus x on the y. All right, on to this next one. I want to give you a chance to solve this. Then I'll do one proof to prove to you that opposite sides of a parallelogram are in fact congruent. So take a second. Find the values of x, y, and z. A hint. Start with the fact that these opposite angles are congruent and solve for x and then go from there. So find the values of x, y, and z in the parallelogram. So we're going to set these opposite angles congruent to each other. 3x minus 18 equals 2x plus 12. Subtract 2x from both sides. I get x minus 18 equals 12. Add 18 to both sides. I get x equals 30. So I'm going to find the measure of this angle. So I'm going to plug in 30 for x in. And I get 72 degrees. So this is 72 degrees. That's 72 degrees in our parallelogram. Consecutive angles are supplementary, so I know that 4y plus 72 has to equal 180. 4y equals 108. Y equals 27. So I'm going to plug that back in. 4 times 27 equals 108. So that's 108 degrees. So 3z must also equal 108 degrees. So z equals 36. So there's x, y, and z. And then we have one more example of proof. All right. So we know one of the theorems is for parallelograms is that opposite sides are congruent. So I want to prove that for you right now. So what are we given when it says that ABCD is a parallelogram? Huh? What this gives me is that opposite sides are parallel. Huh? So remember what we do. We mark our figure and come up with a plan. So if opposite sides are parallel, I know that these alternate interior angles must be congruent due to our alternate interior angles here. And then I also have AC congruent to itself. That's my reflexive property, right? And then when I pop that out, one of these triangles, I end up with those two. So which one of the five triangle congruent postulates am I going to use? Angle, side, angle, and then C, P, C, P, C. Let's lay it out. Here we go. First statement. Reason. So first, we're given that A, B, C, D is a parallelogram. That we are getting. Next, since it is parallelogram, I know that BC is parallel to AD, and that AB parallel to BC. That's our definition of parallelogram. Opposite sides are parallel. We're not trying to prove that they're parallel. We're trying to prove that opposite sides are congruent. So now I'm going to use that and say that angle 1 is congruent to angle 4. And angle 2 is congruent to angle 3. And that's our alternate interior angles here. These lines are parallel, alternate interior angles are congruent. Next, I want to say that AC is congruent to AC. The reason for that? Reflexive. Everyone gets that one. And now I'm ready to show the triangles are congruent. So triangle, make sure we match these up. Triangle ABC is congruent to triangle CBA. My angle, side angle. And if the two triangles are congruent, AB is congruent to CD. And BC is congruent to DA because corresponding parts, the congruent triangles,